Hello, I'm SK Shardin from IIIT IGT Ongol. I'm currently pursuing my third year BTech in Electronics and Communication Engineering. This presentation is about a project IoT based home automation solution that we submitted to Emertxe Information Technologies. This project is a part of our internship. And before diving into this presentation, I just want to give a brief introduction about what we learned so far in this internship. In the first week, we learned about the C programming, and in the second week, we discussed about the project requirements and the design. And in the third week, we learned how to build the units and peripheral programming. And in the fourth week, we had the project integration and testing. And the fifth week, we had the Disha workshop, which is very much useful for our future. And coming to the topics that we learned in the C programming in the first week are we learned some of the basic topics related to the C language, like for example the data types. We have the following data types in C programming, like for example, if we take char, it occupies 1 byte of memory, and int float, it occupies 4 byte of memory, and here double occupies 8 bytes of memory. And we also learned about different type of operators, like arithmetic operators, bitwise operators, and logical operators. In arithmetic operators, we have the plus, minus, into, the division, the by, and the modulus. Coming to the bitwise operators, we have bitwise and bitwise, or the bitwise left shift and the bitwise right shift. And the logical operators in the C programming are the logical and logical or NOR. These are some of the operators that we learned in this internship. And we also learned about some conditional constructs like if, else, and switch case. And we also learned some of the loops which are used when there is a condition, like the for loop, while loop, and do while loop. And we also learned the very important topic in C programming, that is arrays. Arrays are is a collection of data of similar data types. And we also learn about the strings. Strings are also we can say strings as an array of collection ending with a null character. And we also learn about some of the string functions and pointers. Pointers are a variable that holds address of another variable. We also learn about the pass by reference and pass by value. We also saw some of the functions and recursions in the C programming, and memory segments like text, data, stack, and heap. And we also learn about some of the derived data types like structs, unions. And we also got some information about the C++ and OOPS, which is object-oriented programming. And coming to the next slide, the project requirements and design. This is related to the Arduino programming. And in this, we learned about the basic information as what is IoT. IoT here is Internet of Things, refers to the collective network of connected devices and the technology that facilitates communication between the devices and the cloud, as well as between the devices themselves. And we also learned about the home automation solutions and what is the project that we are going to do in this internship and its requirements and explanation. And we also saw how to install the PiximLab. The PiximLab is a real-time emulator of development boards with integrated MPL, ABX, or AVVR GDB debugger. The PiximLab supports some Pixim microcontrollers and some SimAVR microcontrollers. And here we also learned about the Arduino IDE. IDE here is integrated development environment, or the Arduino software, which contains a text editor for writing code, a message area, a text console, toolbar with buttons for common functions, and a series of menus. It connects the Arduino hardware to the upload programs and communicate with them. And we also learned about the embedded systems. Embedded systems is a combination of computer hardware and software designed for a specific function. Embedded systems may also function within large systems. The systems can be programmable or have a fixed functionality. And we also had an overview of the PixSim lab and how to do the programming and all in this week. And coming to the next slide, we learned how to build the units and peripheral programming. Here the CLCD, we use the CLCD to display the output, and we learned about the ADC. ADC is nothing but the analog to digital converter. It is used to convert an analog signal such as voltages to a digital form so that it can be read and processed by a microcontroller. And we also learned about some of the temperature sensor that is used to sense the temperature, and the PWM module. The PWM here is pulse width modulation, is a powerful technique for controlling analog circuits with the microcontroller's digital outputs. PWM is used in many applications ranging from communications to power control and conversions. And we also learned how to control LED using LDR and all. And coming to the project integration and testing, we discussed about the Blink app. Blink app is an IoT platform for iOS or Android smartphones that is used to control Arduino, Raspberry Pi, and Node MCU via the internet. This application is used to create a graphical interface or human machine interface by compiling and providing the appropriate address on the available widgets. And we also learned how to control the heater, cooler, and how to read the temperature using the blink and display it on the CLCD. And we also configured the serial tank in this internship. And the sub projects or things that we did in this internships are: the first one is controlling brightness of garden lights using LDR sensor and blink app. Using the blink app, we control the brightness of the garden lights using LDR sensor. Second one is controlling room temperature using temperature sensor. Here the temperature sensor that we use is LM35, and we all did this with the help of the Blink IoT app. And the third one is measuring and controlling the volume of water in the water tank using the serial tank and the Blink IoT. These three are the things, are the projects that we done in this internship, and the explanation to these will be demonstrated by my fellow teammates further. Thank you.
Hello ma'am, I'm Rama Devi. I'm studying in IIIT IOT Ongole. As a part of IoT based home automation solution, I'm explaining garden lights control. To fulfill this, the requirements are LDR sensor, Arduino board, LEDs. Firstly, we go to LDR sensor. What is LDR sensor? It is defined as light dependent resistor. It is a component that has variable resistance that changes within the intensity of light that fall upon it. LDRs are often used in circuits wherever it is necessary to detect presence of level of light. When we go for block diagram, from the LDR sensor, we are taking the input. It is given to the Arduino board. By using the Arduino code, we are controlling the brightness of LEDs. The output of LED is given to ADC, which is present in Arduino. When the less light, that means more resistance, it is less voltage. Whenever more light, that means less resistance, that is more voltage. The output of ADC. Output of ADC ranges from 0 to 1023. When the V out is equals to 0 for less light, then the brightness of garden light should be more. V out is equals to 1023 for more light, then the brightness of garden lights should be less. Converting the output voltage of ADC to brightness of LED. When the brightness of output LED is more, when the input value is high, where ADC output or natural light is very less. The brightness of output LED is less when the input value is low, where ADC output or natural light is very more. When the output of ADC is 0, it will be B into LED is 255. until output of ADC is 1023. When we get 1023 as output of ADC, we will get 0 as the V into LED. When we go for conversion formula, we are read from LDS. We are read the analog value from LDS sensor and reading and storing the LDS sensor values using ADC. When the input value divided by 4, changing from that 0 to 1023 to 0 to 255. Input value minus is equals to 255 minus input value, converting high ADC values into low input voltage of LED and vice versa. How it is works, it is when the natural light is very low, we will get low output voltages from ADC, and by using the conversion formula we are providing more voltage to output voltage. For suppose we are taking the ADC output as 0, we are dividing that ADC voltage 4. We are taking 0, right? 0 by 0 divided by 4 is equals to 0, and then 255 minus input value, that is 255 minus 0 is equals to 255. We get V in as 255, that means high, high brightness. When the natural light is very more, we will get high output voltages from ADC. By using the conversion formula, we are providing more voltage to the output LED. For suppose we are taking ADC output as 1023, 102, we are dividing that 1023 by 4. We are getting 255. That 255 value, we are subtracting from the 255 value, we are getting 0. We get V in as 0, that means low. By using these methods, we are controlling the brightness of the garden lights according to the amount of presence of natural light. We are taking the output, when we are simulating the garden lights control, we will get these outputs. In the first diagram, the less resistance, we are getting less brightness, and sunlight is more, that's why we are getting less brightness. In the second diagram, we are seeing more resistance, right? That means sunlight is high, sunlight is low, the brightness of LED is more. Simulation of garden lights control. This is the Arduino code. In this, we are initialization part we put here, and this is the conversion formulas. In this, from the LDR sensor, we are taking the values of analog values. We are divided that analog value we are divided by 4, and then we are subtracting from 255. Here we are giving the delay as 100 milliseconds, and then we go for simulation of this garden lights control. In this, we have LDR sensor. This is the resistance. Then lower the resistance, that means sunlight is high, and that time brightness is low. LED of the brightness is low. When we increase this resistance, that means sunlight is low, the brightness of LED is high. When we go like this, resistance, the brightness of LED brights. Then we go for temperature control system as a part of IoT based home automation solution. In this, the temperature control system consists of a heating resistor. In this, we are using the temperature sensor as LM35 and a cooler, which resembles the temperature control system at home. Read the temperature from the temperature sensor LM35 and display it on the CLCD, that means character liquid crystal display. Control the temperature of the system by turning on and off the heater and cooler through the Blink IoT mobile application. When we go for block diagram, we seen that temperature system, we are taking the temperature from the temperature system, and it's sent to the Arduino. And by the Arduino, by the Blink IoT application app, we are observe the temperature in the gas. We are uh, control the heater and cooler by using the IoT application by the data streams as a virtual pins and widgets. We will get the notification in the Blink IoT app when the temperature is above 35 degrees. Uh, uh, like that, we are taking the we are control the heater and cooler by the Blink IoT application and the Arduino, temperature system. We are displaying it on the CLCD board, CLCD, the temperature and notification, that is the cooler on and off, all that are notifications we see we seen on the CLCD. And next, LM35 temperature sensor. These LM35 series are precision integrated circuit temperature devices with an output voltage linearly proportional to the centigrade temperature. LM35 sensor uses the basic principle of diode. Whereas the temperature increases, the voltage across a diode also increases at a known rate. The centigrade temperature is equals to voltage read by ADC divided by 10 millivolts. This is the real-time LM35 temperature sensor. In this we have three terminal pins. In this we have three terminal pins. One terminal pin is for voltage, and another is from taking the output from the temperature sensor, and another one is connected to ground. And next, output voltage of ADC. The output reading from taking from LM35 sensor is provided to ADC. The outcome voltage of ADC is converted into the temperature by using the following formula, that is temperature is equals to n log. We are reading the n log value from pin A0, and that is multiplied by 5 divided by 1023 and divided by float value of 0.01, and that n-log read is used to read the n-log values and provide it as the input to ADC. We go for syntax n-log read pin. The number of pin is the number of n-log input pin to read from sensor and channel values. Now, based on the temperature value, it automatically makes cooler and heater on and off respectively, and displays the state of cooler and heater and display it on the CLCD. For suppose we are taking the temperature is greater than 35 degrees centigrade, then it automatically switch on the cooler, and heater becomes off. We are controlling this using the Blink IoT application in the mobile.
I am Vidyadhari and I am studying in Ajagiri IIIT Ongole. Here the topic is about Blink IoT. Blink IoT is nothing but it is a mobile application app which is used to control the hardware remotely. Blink was designed for the Internet of Things. It can control hardware remotely. It can display sensor data. It can store data, visualize it, and do many other cool things. In this Blink IoT, there are some data streams in which there are some widgets to create the application's app. There are some widgets which are used here are create widgets on mobile Blink application. Button widgets to control heater, cooler, inlet valve, and outlet. Gauge widgets to display temperature and volume of the water in the tank on mobile application. Terminal widgets to display the notifications whenever the threshold is crossed like temperature is more than 35 degrees, turning off the heater. When the heater is on, if the temperature rises above 35 degrees Celsius, then heater should turn off automatically and the message will display as temperature is more than 35 degrees Celsius, turning off the heater. Should it displayed on the virtual terminal as notification in Blink mobile application. Heater off on CLC. Here, the Arduino board does not have any direct communication through online or Wi-Fi. To make communication with an Arduino is possible by using the external communication peripherals like Ethernet shield. Here, there is a Arduino code to temperature system. It is like here. We are initializing the temperature system like cooler and heater. These are the output ports. And here we will distill right the cooler and heater and keep it as a low values. Here the temperature is reading as float values. Here float temperature. To convert these distill values from ADC to temperature, this degree Celsius. Here our temperature is the degrees is Celsius degree. And here we will read the A naught as analog read and multiply it with float into 5 and divided by 1023, and again it is divided and it's multiplied with 0.01, and we return the temperature. Here this is the formula of the original temperature in degrees Celsius. Here we control the cooler and heater values and we will distill write them, and here the values are taken as boolean values. So this is the Arduino code. To simulate this, we will go to Pixim Lab and simulate it. For that purpose, we are using the Blink IoT app, which is here. Here, see, here the cooler and heater. The cooler is on. Cooler is on, and this is the AC, which is this is a cooler which is acts as an AC. Here it is turning and it is cools down the room temperature, and the less value of the temperature is 27 degrees 37 degrees Celsius. If we want to heat our room, we will on the heater button, and the heater button has the maximum value of 35 degrees Celsius, and it will get automatically off, and we will get a display value as notification as temperature is about 35 degrees Celsius, turning off the heater. This is the function of ESCV. The heater button has turned off automatically. So this is the cooler and heater button simulation with the use of Blink IoT app. Serial tank. Serial tank is used on home automation. It is a part of home automation. Serial tank is nothing but the water content which is used to control the water supply in a home. To control the water supply in a home, we are using water tank inlet and outlet valve to control. Here, to control this all the performances, here we use serial communication, and to display the commands in CLCD, we use CLCD and serial communication. To read the volume of the water in the tank through serial communication and display it on the CLCD. Control the volume of the water in the tank by controlling the inlet and outlet valve by sending commands to serial communication. Display the volume of the water in the tank on CLCD and also have control. This is the block diagram of Blink IoT app and Arduino and water tank with CLCD. Here the Blink IoT app is connected with the Arduino UNO. Here the inlet valve control and outlet valve will control with the Arduino UNO. And these Arduino UNO sends the notifications to the Blink IoT app and also notifies the volume of the water. These notifications are coming in the gauge widgets. Here the Arduino UNO is also connected to CLCD, which displays the notifications like here the value inlet valve is on, inlet valve is off, the volume is 3000 liters, like that. Here the volume of water is also displayed in CLCD. Here this Arduino UNO is also connected to water tank, inlet valve control and outlet valve control, and volume of the water also. This is the block diagram. Here the volume of water is decreases if the outlet valve is turned on. When the outlet valve is turned on, automatically the volume of the water will decreases. This displays in the CLCD as outlet valve is on. If the volume of water is below 2000 liters, the inlet valve will automatically turns on and sends a notification message like water level less than 200 liters. 2000 liters and inlet valve is turned on. This message is displayed in the Blink mobile application and also in the CLCD. When the water in the tank is full, turns off, then the inlet valve turns off automatically and displays as water level is full water. Inflow is disabled. This is the control serial tank structures like this. So to control these, we will use a Arduino code. The Arduino code for serial tank is here. Here we use unsigned integer and character values for the volume, and the values to the for volume we'll use the integer values, and for the values we'll use the character values. This is the initialization. Here we use the serial begin, serial write to know the values of that. The unsigned int values, here we will use the loop statements also for the data availabilities, and serial read and serial available, and we'll return these values also. Here we enable the inlet and outlet values and disable the inlet and outlet values also with the help of serial write function. So this is the brief note of uh, Arduino code of serial tank here. So for the simulation of after the Arduino code, we will go for the simulation. Here, this is the tank which is full of water. This blue color indicates the water. Here the inlet wall flow which is it have the fixed values we will disable it. And again we will connect these with the Blink IoT app. Here see the inlet wall and outlet wall both are off and the volume is 3000 liters. So here for the outlet wall when the outlet valve is on, see the decreasing of water is seen here. We are observing the decreasing of water. After at the perfect of 2000 liters, the outlet valve here see the volume is 1870. So the decreasing of volume is automatically stopped. So here the inlet valve is also on. Water see the notification is water flow is less than 2000. Inlet valve is enabled. So here the 2000 liters of volume outlet valve is decreased, then the inlet valve is also on. So for that purpose we have to off the outlet valve and inlet valve also. And again if we on the inlet valve here. See this is the purpose of the inlet and outlet valve controlling of Blink IoT. And here we display the in CLCD as here. Inlet flow is on, inlet flow is off like that. It will be displayed in the CLC. So this is the full purpose of serial tank applications in the using the Blink IoT and this is the code also. And here in this IoT, Emertxe IoT internship, we have learned a number of new skills, which is C programming, introduction to C++, and some of the introduction to IoT, and project requirements which are used for the development of the project and designs also. Introduction to embedded systems, familiar with all tools used in IoT and Arduino programming. Blink app or configuration, installation of PiximLab, Arduino IDE, null modem emulator, Arduino Uno overview and everything. Here, coming to the conclusion, the internship at MX Industries helps us in learning MX Information Technologies help us in learning various new skills. We have learned concepts like C, C++, IoT, and Arduino programming in this internship, and worked on the IoT-based home automation solution project and simulated in Pixim Lab. And we also used it for the Arduino for code also to do the programming. It was a very good experience for us to work with MX, which helps us to work in real-time problems using IoT. Thank you.
We really want to thank Emertxe for giving such a great opportunity for all the students.